Now we'll try to set up a small Java project, simple Java project, and see how this code completion and suggestion feature works, and also what is the use of slash explain, and also how to debug our code and fix it by using slash fix expression, and also how to review and refactor our code. Okay, so these things, right? We have this slash explain or slash fix, which are only available for VS Code, and also you can leverage them in GitHub Copilot chart. So in case of if you are using STS, these features won't be available for you. You will get only the feature like code completion or suggestion feature. That's it. So first we'll go to STS and complete this simple Java project with the code completion and suggestion feature. And after that we will open our VS Code and complete all these steps. Okay, so for the first thing, we'll go to the STS and do the thing. So I'm opening my STS here and I'm going to create a small test project now. So for that, I'm going to here and right clicking in the package or file explorer and go to here and I'm going to create a small simple Maven project. Okay, so here I'm going to use the default workspace next, and here I'm going to use the quick start archetype for quickly starting our Maven project. And here the group ID is com.github.copilot. Okay, that's fine. And artifact ID I'm going to add as simple Java. Okay, so this is our artifact ID and version. I'm keeping the same snapshot version and finishing our project creation. So the project creation itself takes some time, so we need to wait. And here you can able to see it in the below. The project is trying to build. So oops, let me fix it properly. Okay, so here in the console, if you see, the project is building and it's asking about packaging. So should we are using this package? Yes, right? com.github.copilot.simple.java. Yeah, I'm going with it. And yep, our project has been created, that is simple Java project. Okay, so now inside this simple Java project, we'll see what we can do, right? It created two things for you, two files for us. One is app.java, which is the main class in main package, and inside the test package we got app text. So we'll do one thing, we'll delete these files which was generated through Java or our STS, right? I'm deleting this file app.java and also app test file from my project. So I have deleted those two files and now I'm going to create a file and see how my this thing works, the GitHub Copilot works, right? So for that, first I'm going to our simple Java and I'm going to create my new file. So I'm going to create my class, and here my class I'm giving some meaningful name. So in this case, I'm going to give a simple Java program, that is prime number. Okay, so the class name is prime number. That means this class will have a method. That method will calculate say given number is prime or not. So prime number class is ready. So now how can I leverage the GitHub Copilot features? So first we will see what happens if I enter here into our block. So I'm clicking some enter and wait here and see the magic. So if you see here, right, you got this code suggestion, right? This is your code suggestion feature. Here it is giving some main method. From the main method, it is calling isFrame method, right? Which is a static method which takes a number and checks for is a prime or not. Based on that, it is returning true or false. If it is a prime, it will return true. If it is not prime, it is written false. Okay, so I think I'm good with this code. Even I have the main method here, right? So this is auto, this is code suggestion. Now how can I use auto completion feature here? Just click on tab so that your code will be entered here. That's it. Boom. You don't do anything here. You just given a meaningful name to your class and it created the required thing into your class. right? We'll see whether it works or not. I'm just running my application. So if I run my application, you can see, right? 5 is a prime number and 6 is not a prime number, which is true, right? The code is working. You don't take any much time here, right? It created within seconds. So that was the beauty of GitHub Copilot, your AI pair programmer. Okay, we'll see few other features, right? So I'm going to create another method. I'm saying a comment, right? Implement. So it is automatically giving some suggestions to me. Look, implement the method to print the first n prime numbers. So it given this auto completion. So yeah, I need this method also. So I'm clicking tab to get this comment. Now if I click on enter and wait for some time, it's creating one method for us, that is print first n prime numbers, and we are providing the n value. Based on the n value, it is printing all the n prime numbers. So if you like this code suggestion, click on tab for the auto completion. So I clicked on tab and I got this method. Okay. Now if you want to call this method, right, you just go here and just try to enter, right? Sometimes it will understand our requirement by itself and it's giving the code suggestion like print first n primes. Great, right? It is showing everything. Whatever I am thinking, it was able to show it. So this code suggestion, I like it, and I'm going to type tab to get auto completion. So it's auto completed. Now I'm going to save it and I'm going to run this program. And if I run this program, if you see here, all the first 10 prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, the 10 values has been printed. Wow, this was fascinating, right? We haven't spent much time here. It created these things for us. Wow. No, right? These are good. You have seen all the auto completion features, and based on your meaningful class name, it's generating the methods inside it. Even if you provide some comment here, based on the comment, it is generating methods inside it. It was good. Now, if you want to write some test cases for these classes, right? How can you leverage here? So here inside the STS, as I mentioned, the functionalities is very less because we don't have GitHub Copilot chart. But you will get this auto completion features and you can provide these comments and get your work done. So to implement JUnit test cases, right? To implement JUnit test cases to this file, we'll do one thing. We'll go to our test folder and add a new class. So I am giving name as prime number test. Okay, so this will write JUnit test for prime number class. So for that, you just try to go to inside and see whether anything happening here. And if you see here, it is generating the same methods, right, which we have written inside our prime number. But this is not what we require. We need JUnit test cases. So for that, you need to mention above like implement JUnit tests cases for the prime number class with path. So you can provide the path also, and it will try to fetch the path. Yeah, so it is fetching the path from prime number test, but it is not the case, right? The path should be source main. So if you are typing, it will try to fetch the class prime number.java. So now we are fine, right? Implement JUnit test cases for the prime number class with path. So if I go inside my class, just click on enter and you can able to see it is writing test case. Okay, so this is not required for us. So we'll do one thing, we'll write our comment in such a way that it will create JUnit test cases for us. So the implement JUnit test cases for all the methods inside, right? Prime number class with path main Java. Yeah, it's giving the auto completion, right? It's giving the code suggestion. You click on tab to get auto completion and save it and go inside your prime number test and see whether it is providing any JUnit test cases. Wait for some time and it will provide some JUnit test cases. And if you see here, still we are not getting proper response. So we'll do one thing, we'll change our comment in another way. So I will do one thing. So first I will write implement JUnit test cases for the prime numbers class, and with use the JUnit framework, and use the class from path source main prime number class. Okay, so we'll see now. We have provided three comments. We have told him to write test cases for the prime number class methods. We'll say methods, and also, and we have provided it to use the JUnit framework and also ask it to use this file. So now we'll see whether what it will happen here. So wait for some time till it creates you the test cases. Now it created test cases, right? But in a textual format. It's not a code. So we are not going to accept this, right? So we'll say JUnit test cases, JUnit test cases code. We'll see now. I will go inside this method and again I will click on enter and wait for some time whether it creates for me or not. No, it's not working. So it's still not creating me JUnit test cases. Okay, so we can ignore as of now. So we'll remove the first comment. Use the JUnit framework to the test the class. Okay, we'll go inside and see now. Yep, now it created a test case for us. So what I mentioned here, use the JUnit framework to test the class prime number and the path of the class I have provided, and it created a test case for me. And if I click on tab, right, I can able to accept that auto completion. Fine. And here few things are missing, right? Few dependencies are missing, so we need to add JUnit dependency into our project. So for that, go to your pom.xml, check any dependencies here. So here we have JUnit dependency, but which was not a latest one. We'll do one thing, we'll remove this dependency and we'll try to add JUnit dependency. So since I type enter here, the GitHub Copilot understands that we need JUnit dependency. So it is trying to create a dependency for me. So that is 4.12. So I'm happy with it. So I'm accepting and saving it. Now I'm going to prime number and we need to import all this. So hover it and import test, and hover it import asset true and even asset false from the JUnit things, right? The byte array output stream from java.io and print stream.java.io and asset equals from JUnit. Okay, now we are good with our test cases. So I have spent some time here, right, to get GitHub Copilot to understand my comments, but it created my test cases easily. So here in these test cases, you can run your JUnit like run as JUnit and see how it works, right? You can able to see your two test cases getting passed. This was fascinating, right? This was very good. So we have seen the code completion or the auto suggestion, the code suggestions and auto completion feature here, and also leverage the use of the comments to create our files, or leverage the use of the the class name itself to create entire code inside the class, and also we have leveraged our comment section to get JUnit test cases for this file, right? So these are very limited one case of STS, right? In STS we don't have GitHub Copilot chart, but when we go to VS Code, the Visual Studio Code, you will get a feature called GitHub Copilot chart by using that feature, and also the expressions which I mentioned earlier, right? The slash explain, slash fix, those kind of things, and also you can interact with your code and you can select in particular line to the end of the function and check up until that particular selection, any bugs or any review or any refactoring, right? You can do any such kind of things or any comments you need to add on top of that code. You can use that GitHub Copilot chart. So now we will see that in a minute. Okay, so we will move on to VS Code and see how GitHub Copilot and GitHub Copilot chart works, right? Now we are going to do these things, this simple Java project where we are going to explore code completion or suggestion feature along with slash explain usage, and also we are going to debug and fix the code if any issues there, and also finally we can review it and refactor it as per suggestions given by GitHub Copilot. For that, just open your GitHub, right? And I hope you have set up your GitHub Copilot here. So go to your project explorer, and here you can able to write your code. So here you will have this option called create Java project, and I am assuming your VS Code is ready for your Spring Boot and Maven projects, right? And I'm hoping that if you should not just set up your Visual Code in such a way that you can able to create your Java projects and Spring Boot projects and run it. Okay, now I'm going to create a simple Java project now, and here it is asking for me for the build type. So I will use the Maven from the selection, and here we can select the quick start itself. So as of now I'm going with no archetype, and here it is asking for me for group ID. So I will give the group ID like com.github.copilot, and my artifact ID is simple Java. Okay, so it asked me to select one folder in my local computer. So I'm going to select one file here. So I'm going to downloads, and I'm going to store my project in the downloads folder. Okay, so I'm selecting this destination folder, and the VS Code will set up our project. So you can able to see it. Maven project simple Java is created under this folder, and do you want to open it? Yes, I want to open this project, so I am clicking on this open button. So it's open my simple Java project, and here we are going to explore the options what we discussed earlier. So the options we are going to discuss here is code completion and suggestion feature first. We have already seen this feature in STS. Now we will explore in VS Code IDE. So in VS Code IDE, we'll see that. So go to source and check whether any files created by Java, right? Since this VS Code has been created a main class for us, so what I'm going to do is I'm going to delete that class as of now. So delete this class, and similarly delete any test classes it generates. So I'm going inside the test and check. So it's not created any test class. So we are good with it. So now inside our package, in our Java package, so what we are going to do is I'm going to insert a file, and the file name is the same thing, which is prime number file, which we did for earlier, right? So we need to add extension also. So I need to edit it. So right click and rename it prime number dot Java file. Okay, so it represents J to show the Java files. So the Java file is created. Now we can able to generate our prime number class using our GitHub Copilot. So here you can able to see your GitHub Copilot status, and you can able to use the GitHub Copilot chart, right? Completion panels, you can disable these options. So these are all options you can play with, but as of now we are going to see how the code suggestions and auto completion features will work. So in case of here, right, VS Code, it is saying control plus I to ask GitHub Copilot chart to do something. Okay, so we'll try this. So control plus I, it has opened this panel. It's similar to our chart, right? So this is somewhat different to the STS where you have added your class name, and after that if you click on enter only it generated the code. But here if you click on control plus I itself, it given a chart box. In this chart box, if you provide some class name and what this class will do, Copilot will try to generate code for us. Okay, so we'll do that. So for that, what I'm going to do is I'm going to say create a class called prime number, in which I need two methods. Okay, so the one method is two methods. First one, to find the given number is prime or not, and second one, a main method to test the prime number, to test the first method, right? To test the first method. So we'll see how the GitHub Copilot chart will understand our prompt and create a class and also the methods which we described. So I'm going to click on this thing and we'll see how GitHub Copilot generates a class. So if you see here, I am not doing anything. GitHub Copilot itself generated this class for me. So see here, it's generated a class prime number, and inside it we have an isPrime method which check for the prime nature of a number, and if it is not a prime it returns false, if it is a prime it returns true. Okay, and here in the below if you observe, it created another method called main method which have a number which was initialized to 17, right? And also it given you a comment to you, you can replace with the number you want to test. Okay, so using this number it is sending to our isPrime method and checking the prime nature of a number. If it is a prime, it is printing it's a prime number, otherwise printing is a not prime number. So it's fascinating, right? It's very interesting when you see this thing, right? You have given some text here which was human readable or human daily usage language, right? The English one. And what he did is it converted that thing into a class itself. It written method for you. And this code, right, you can able to accept here or discard here or even regenerate another version of code. So I think I'm good with this code. I'm going to accept it. Okay. And it created this thing to you. So click on save and see here it's showing some error. The declared package. So it's we need to declare the package also. Here click on this quick fix which will asking us to add package declaration. Just click on this add package declaration and that will handle the code. So if you see here, your code is ready, right? We'll try to execute now. We'll say run Java and see the console, right? 17 is a prime number and it's working as expected. It's fascinating, right? It's very interesting. And even right, as we discussed earlier, you can add a comment like implement implement a method to find first and prime numbers and click on enter and it will give you the code suggestion, and here you can tap for accepting it, or here it will give a different versions for you. So if I click on this arrow button, it has the another version, otherwise you can go back to the previous version, right? You can even accept by word to word, right? And you can even accept everything by using tab. So I'm good with it. I'm clicking on tab, right? This method also created, right? The same thing we have seen in STS, the same thing happening here, Visual Studio Code, but here you are using one thing called GitHub Copilot chart also, right? This thing we have already did with STS, but the thing earlier we did, right? Creation of this class itself with the methods, right? With using GitHub Copilot is not there in our STS. So yeah, from until this we are fine and we'll go and explore the other features. So we have seen the code completion and suggestion feature, the code suggestion and auto completion, we can call whatever it is. And we are going to look at explain uses. So what is slash explain? So we'll see that. So just go to your Visual Studio Code. Okay, now what is the use of slash explain is we are going to know what is happening inside this class or what is happening inside this method, right? And if you don't know about it, you will ask GitHub Copilot to explain to yourself. So how can you do that? For that, you have to open your GitHub chart. So here in the below, you will have this option called chart. Click on it. So here you will get this chart GitHub Copilot where it is saying welcome at the rate your name. I am your Copilot and I am here to help you to get things done faster. You can also start with an inline chart section using Control A, which we have already did, right? Inline chart section. I am powered by AI, so surprises and mistakes are possible. So it is accepting there will be some mistakes. Make sure to verify any generated code or suggestions and share feedback so that we can learn and improve. Check out the Git Copilot documentation to learn more. Okay, fine. So now here it is giving some options, right? Slash fix the problems in my code, slash add, slash tests, add unit tests for my code, and also slash explain how the selected code works. So we are going to explore this slash explain. So for that, we have added this method, right? So I'm going to select this piece of code. So I have selected from line number 20 to line number 34 in prime number class, and I'm going to add a slash command, that is slash explain, right, which is under our workspace. So this annotation represents in the workspace in this lines of code we're explaining. So just keep explain and enter. So what it is doing is from line number 20 to 34, it's trying to give us explanation. So just look at this explanation. So I'm enlarging it for your better understanding, and just look at the GitHub Copilot explanation. The provided code is written in Java and a part of a larger program. It consists of two methods. First, n prime numbers and is prime. The is prime in number method checks if a given number is prime, and a prime number is a natural number greater than 1, and it given the description of the prime number and how is prime works. But we need this method. The first n primes, right, method uses is prime method. So why it's explained is prime method? Because the selected method is using is prime. To find the n prime numbers, it starts by initializing an array of size n. To store the prime numbers, a count variable to keep track of how many primes have been found. This is the count. And a number variable starting at 2, the first prime number. So number 2 is the first prime number. So that's why it's starting at 2. It then enters a loop that continues until n primes have been found inside the loop. It checks if the current number is prime. If it is, the number is added to the prime array and the count is incremented. Whether the number is prime or not, the number is incremented at the end of the each loop. Once n primes have been found, the method returns an array of primes. Okay, so this is fascinating, right? This is very interesting. It gives a code, literally all the explanation what is happening line by line, even what a variable will do, right? So this was very a useful feature, I would say, and you can leverage it for your day-to-day development activities. We have already seen slash explain uses, and we'll go further. We have debug and fix options. So in the debug and fix, so how to fix a problem in our code and how GitHub Copilot chart will help us to fix a problem. So for that, go to your Visual Studio Code and we'll see that. So for that, I need a bug code, right? I need a particular function which has some bug in the code. So for that, I'm going to write one more function. So I'm going to, so before that, I am requesting VS Code or Copilot, right? So you can use Control I or you can add in normal comment. Okay. So here you can say that you can also type for slash for comments. You can add slash also. So here what I'm going to do is simply I'm asking GitHub Copilot. So what it has to do? So I'm asking implement a method called factorial in recursive way. So I'm implementing a method called factorial in a recursive way, and if you can able to see, right, it created an factorial method in a recursive way. So if you like this, you can accept our Discord, or you can able to regenerate another piece of code. So I am okay with it. I'm just going to accept it. Okay, now I have this piece of code. Now what I'm going to do is I'm going to use that slash fix expression to check whether this piece of code has any debugs or bugs. So if I select here and in the GitHub Copilot chart, if I use slash fix and ask for a, so debug and fix any issues. So if I do like this, what will happen? The GitHub Copilot itself do the thing. So we'll see what it is giving back to us. So here it is giving a piece of code for us, and we'll see. The provided code is recursive implementation of a method to calculate the factorial of a number. Okay, the number of a factorial, the factorial of a number n is the product of all positive integers less than equal to n. The code seems to be correct. It has a base case n equal to 0 where it returns 1 since the factorial of 0 is defined to be 1. Okay, for all other cases it returns n and the factorial of n minus 1, which is the correct recursive formula for the factorial. But however, there is no check for the negative inputs. So for example, if I give some negative input here, this will break. Okay, if n is negative, the method will go into an infinite recursive loop because n will never reach to 0, because here base condition is 0 and n will never reach to 0, so it will fail. So GitHub Copilot able to find that issue, right? Able to find the issue in this, and to fix that issue it has given this code. So to fix this, we can add a check at the beginning of the method and throw a exception if n is negative. So if n is not negative, it will, if n is negative, and in this case it will go into an infinite loop. But here if n is negative, it will throw an illegal argument exception, and which says n must be non-negative. So if it is a negative value, it is throwing this error. Okay, so like this you can avoid any potential infinite loops in the future. Okay, we can copy this piece of code and replace this. So before that, we'll see whether it will go into the infinite loop or not. So what I'm going to do is in the main method, right? In the below I have main method. Instead of calling this prime number, I'm just commenting this piece of code and I'm going to call this method. So what is the method? Our factorial method. So I'm going to call factorial and number should be 70. Okay, number should be 17, and we're going to print that factorial by using system.out. So since if I print this, we'll see what will happen. So I'm just going to minimize our GitHub Copilot a little bit and maximize our terminal to see any potential issues. Okay, now I'm going to try this as an, now I'm going to run as a Java application and we'll see what will happen. And the value is minus 288,522,040 is the factorial of 17. So what if I have given minus 17 here and save it and again try to run the code, and you can see, right, it got failed. The code got failed. You can able to see here it executing something and it is showing some error at line number 40, that is here. So it is recursively calling the method and able to, because there was some issue in the code and it is recursively calling and it is undergo into an infinite loop. Okay, so it got failed. Okay, so if a negative value if we given and we are not getting proper exception here, so we can use this piece of code instead of that and just replace this piece of code with a new code and save your code and try to run now. Okay, and see, you will get a much meaningful exception, that is illegal argument exception and must be non-negative. So now you have fixed this issue by using GitHub Copilot itself instead of breaking your heads, right? So use just slash fix and it debug the code and it fixed the code. Okay, now come back to our slide and see the next thing is review and refactor. The next point is review and refactor. We'll see how GitHub Copilot will review your code and refactor your code. For that, go back to your Visual Studio Code and here we'll use the same factorial method and try to review and refactor it. So what I'm going to do is I'm going to select this factorial method and going to type here just review and refactor code if any potential improvements required. Okay, now we'll see. So it is taking from 36 to 45, that is here to here, and it will do some improvements to our code. Okay, we'll see what it will give to us. So it is generating some piece of code for us. We'll see. The provided code is a recursive implementation of a method to calculate the factorial of a member. Okay, so for a number, it is a recursive implementation to calculate the factorial. Okay, it currently handles the base case where n is 0 and throws an illegal argument exception when n is negative. However, recursion in Java is not as efficient as iteration due to the overhead of the function calls. If the input number is large, it could be lead to a stack overflow error. Okay, so we can refer to the code to use iteration instead of recursion. So recursion will result in stack overflow, right? Because you are calling a function recursively and it is storing into a stack, and at one point of time your stack will be overflown and you will get an error. So to handle that, right, instead of using this recursive approach, what GitHub Copilot is suggesting is to use an iterative way so that you won't get into that issue, right? And you can copy this code and paste there for the potential improvement because you are not going to get any stack overflow errors now. Okay, I'm pasting it here and saving. And if you execute the and run the Java function, we'll get the same error because we are passing -17 here. We'll pass some 7 value and save it and run Java. And you can able to see right 5040 is the value of 7 factorial. Okay, that is fine. And we'll see is there any potential improvements in this iterative approach itself. We'll see. We'll do the same thing. So we'll select this piece of code and we'll ask. So review and refactor the code for any potential improvements. So it will again try to review this code and refactor. So we'll see what will happen here. So it is again going to review this code and refactor for an optimized way, right? Effective way. So the provided code is an iterative implementation of a method to calculate the factorial of a number. Okay, it's correctly handled the case when n is negative by throwing an illegal argument exception. The factorial calculation is done using a for loop, which is efficient. Okay. However, the method uses int for the result, which can lead to overflow for relatively small values of n. Factorial grows very quickly. To handle larger values, we can change the result to be a type of long. So since we are passing an integer value which has a greater value of 2 power 31 minus 1, which if we cross our value, which will result into an overflow of integer value, right? So then to store the larger number, you have to use some other data type like long. So here again, the GitHub Copilot improved your code to use long data structure instead of int for future issues like overflowing integer value. So by using this code, right, by using this piece of code, you can handle a larger numbers because factorial will be increased very quickly. So you can use this piece of code instead of this to face this kind of issues. So I'm copying this code and again I'm pasting here into my file and saving it. And if I execute and run Java, again I will get the same output, that is 7 factorial, and now the code is very efficient. It will handle most of the edge cases like stack overflow and integer overflow, right? It will handle the largest numbers also. So that is the use case of and use of this reviewing and refactoring.